All right, guys. Good morning. How you guys doing? Uh, Top of the morning to everyone. I hope you are enjoying the weekend. So this very morning, we want to talk about something quite very important. I decided to make it like this because I noticed that many of you may have issues with it. So I really want to tackle it a bit intensely. It has to do with percentile in normal distribution. So, and I'm also going to use this to explain how you're going to be able to find the X score, the hex score from the Z score. That's something else you guys need to also understand how to do, where you know the Z score or you find the Z score, and from the Z score, you are able to get the corresponding X score. So, guys, let's get right into it. Now, during one of our classes, I told you guys about there was an example we solved during our classes, one of our classes. If you have your note right there, you can turn to the question that has to do with the height of adult American male. That question, you can turn to it. So there's a question that has to do with the height of adult American male. So and so we solved two of the questions there. Two of the questions. The first question was the probability that the height is taller than 180 centimeter. And then the second question was the probability that a randomly selected adult American male has a height between. All right. So the question said, what is the 90th percentile of the height of American male? Now, I would have to give you guys the data that has to do with this question in case you don't have it there. So for this particular question, we're told that the mean was equals to 176.3 centimeter, and the standard deviation was equals to 7.1 centimeter. All right, this was the parameters we were given. All right, now I don't want to go on to solve question 1 and question 2 since we have done that already. The major focus in this particular class is to talk about how to find the percentile. The question said, what is the 90th percentile of the height of American male? The 90th percentile. So this is, let me give you a review, although I explained this already while we were discussing about quartiles percentile. But let me give you quickly a review on percentiles. So what is percentile generally? Of course, I told you guys that the total percentile you have is 100. So your percentile can range between 1 to 100. You have, let's say we have this is 100 percentile, the first percentile, and so on. So we can talk about the 50th percentile, we can talk about the 75th percentile, we can talk about the 25th percentile. And I told you guys the relationship between percentiles and quartiles, if you guys remember. Now, but the major thing I want to explain right here is how do you explain the use of the word percentile? What's the interpretation? Let's assume I told you that, let's say you had a test score over 50. Pay attention to this. If you had a test score and the total mark, the test total score was 50. So of course, a student gets everything when a student gets 50 over 50. Now, let's imagine I told you guys that the 75th percentile is equals to 38. So the main question here is, what does this actually mean? What does it mean for you to say the 75th percentile is 38? Now, this is the meaning of this. It means that of all the people in the classes, whatever number you were, it means that 75% of people had either as small as this score or smaller than this. Let me repeat that. So let's say you guys are like, I don't know, let me say you are 30 in the class. Let's say you are 30, or let's say you are, let's say you are 30 or you are 20 or 25, any number. Let's say there are 30 people, total number of students. We have, let's say 30. Now, every one of them has scores. Of course, every one of them have different scores. We have, of course, we have different scores that these 30 people had. So let's say we had 30 different data points. For instance, 30 different data points. Somebody had 35, somebody had 34, somebody had 39, somebody had 43. We had different data points. I don't want to go out to be listing possible data scores here because it's not really necessary. You guys should be able to understand what I'm saying using it. So we have 30 different data points. These 30 students had marks. What I mean by data points in this case would be different scores. All right. And don't forget, the total score is over 50. So I came on to you guys now and I told you guys that the 75th percentile of the test score was 38. The question is, what's the interpretation of that? What this means is that, as I said, 75% of the data point, that means of the total of the student score, 75% of it is either is as small as this or smaller than this. That means 75% of the data score had 38 or less than 38. That means, for instance, it's possible that, just let me give you a very important thing to note. The whole 75 people may have 38 as their score. That means if 75% of them, of these 30 people, 75% of these 30 people had 38, it's still correct. That's why I said 75% of people had as small as this. That means they had 38 as a score, or they had lesser than 38. That's the meaning of 75th percentile. So the use of this percentile, especially in a case like this, is used to interpret where the class is at. So if 75% of people, imagine I said the 75 percentile was 24 over 50. I hope that's like a massive number of people failed the test. That means 75% of people of the data point had 25 or less than 25 if this 75 percentile was 38. Now, if I say 25% was 38, that means, of course, there was not a very high percentage of people that passed, but at least 75% of people had 38 or lesser than 38. That's what you use percentiles for. Let's take another instance. Let me use a different way to explain this. If I say 75% of people had 38 or smaller than 38 or smaller or less than 38, I can also say in the same vein, the meaning of that will mean invariably that 25% of people add higher or high as this. So it's like this. If 75% of people had as small as or smaller than this, of course, that means the remaining 25%, of course, 25% is 38. That means the remaining 25% had higher or as high as this. That's just the way you need to understand this thing. So when we start talking about 90th percentile, I want you guys to be able to flow with what we are saying here. 90th percentile will mean actually that 90% of the adult American male has, when they say what is the 90th percentile of the height of American male, 90th percentile, that means you are looking for an height that 90% of American male will have either exactly that height or less than that height. And the meaning of that will also mean that 10%, the remaining 10% will have above that height or exactly that height. So I'm going to draw a diagram to try to explain this, just so you understand the meaning of 90th percentile. So let's say we have, of course, this is a normal distribution. All right. Our mean is at the center. You know this already. It's symmetric about the mean. All right. Now, if I'm trying to talk about the 90th percentile of the height of American male, as I said already, using this example right here, that means when you are seeing a question that says 90th percentile, that means they are saying 90% of the American male, 90% of them, that height you are looking for, that means 90% of them will either have that height or less than that. So if this whole thing is 100%, of course, this whole curve represents the whole American male, right? That means 90%, I'm going to rule a line around here. All right, because if this is 100%, 90%, I can shade this whole place and say this will be at least 90%. So I'm looking for this core. I'm looking for this core right here. This core right here. Because this core right here now will represent a score in which, look at all this, of course, 90%. A score in which 90% of American male will either have this score or less than this score. You can see, that's why we're shading this side. Either this score or less than this score. You need to always include either it or less than. Don't focus so much on just saying less than that score. No, they can have that score or less than that score. The meaning of this also will mean that this remaining 10% that we have not shaded, 10% we have above that score or exactly that score. That's how you deal with percentiles. Understanding this thing I just said will give you good headway in solving any questions regarding percentiles in normal distribution. So now, look at the other side to this now. All right. In this scenario, I believe you guys have understood the interpretation of, the center I was looking for. I'll be shading only at that point. Add this score or less than. That's the meaning of 10th percentile. You can see if I say this is 10th percentile, that means they either have this score or less than this score. I told you guys always include the word they either have that score or less than. Don't just focus on less than percentile of the height of American male. That means I'm looking for a score in which 10% of the people will have either that score or less than that score. And another way of seeing that is that 90% of the other people will have higher than that score or that score. You can see if this is 10%, 10% are having that score or less than it. Of course, if you say find the 10%, that means 90% will have higher than that score or less than that score, or exactly that score rather. That's the way you deal with percentile. So let me give you one last summary. When I started with this, I said you have a test score is over 50. If I said the 75th percentile is 38, what I'm saying there is that 75% of people in that class either this score 38 or they had less than 38. Now, if I wanted to say it in a different way, I can say that means, of course, the remaining 25% will have higher than that score or this score. That's just the meaning of percentile. So when you are drawing your diagram, you should know how to represent it properly. Now, the other side of this thing now, which I said I was also going to use this opportunity to explain, is that you know already that we don't have we don't have a normal distribution table. What we have is a standard normal. That's what we call the Z table. So obviously, you know that it's not possible for us to, if we had a normal distribution table, we want to be looking for that one that has a mean of 176.3 and standard deviation of 7.1, and then we'll then use it to find what this space will be. Now, guys, let me quickly say one thing before I move on here. If I said this was what I used to represent 90th percentile, I'm sure you guys know, and I'm sure you guys should know. Okay, let me ask on the comment section, what's going to be the area of this spot right here? This spot, tell me, let me call it area A, and let me call this area B. So guys, tell me what will be area A and what will be area B. Let me get responses. What will be area A and what will be area B? Don't forget, this question I'm trying to for 90th percentile of the height of American male. Thank you very much. I love the answer. I see 0.9. So simple. So if I told you that 90th percentile, that means I'm saying 90% of the people. So I'm saying this from here downwards represents 90% of people that had this score or less than this score. What will be area B? Area B will mean 10% of people, of course, the remaining 10% had that score or higher than that score. So that means area A will be 0.9 and area B will be 0.1. It's that simple. So now, if I had, for instance, a table, a normal distribution table that had mean of 176.3 and standard deviation of 7.1, I'll go on out to just check for, the area of 0.9, what was the Z score that produced an area of 0.9? I'm sure you guys remember that I told you already that you solve your table from left to right. So in this case now, if I wanted to find this score, I will go on to look for an area of 0.9 and ask myself, what score produced an area of 0.9 when I had a table that had mean of 176.3 and standard deviation of 7.1? But the truth is, you guys know this already, we don't have any normal distribution table that mirrors this parameter 176.3 and 7.1. You guys notice the use of my word parameter. I'm using that intentionally. So you guys know already that we cannot use. So let's assume we are tackling this on a Z, in a Z situation. I'm sure you guys know that I'll be having 0 now, and the same, of course, the same thing. Looking for, this is where I'm looking for. Of course, you know already that this is 0.9 and this is 0.1. So guys, you will have to now go into your Z table because you cannot use, you don't have a, is anybody still with me? Some people are talking about network. Are you still with me? Is there anybody still listening to me and saying properly? Clearly? Okay, it's all right. Thank you very much. Now, this is the thing. You don't have a normal distribution table that can give you answer here because you don't have any normal distribution that has 176.3. All you have is a Z table. So let's push this back to a Z table now, and we want to find this. So guys, you can quickly go to your table and find what is that Z score that has an area of 0.9. That's so easy. What's the Z score that produces an area of 0.9? I'm sure you guys already know how to find that. You may not be able to find an exact value. Sometimes it's in some cases you'll find exact value. Sometimes you will have, as I taught you already, you have to go in between. So like it's probably 1.64 and 1.65. They are both as close to 0. To whatever value you're looking for. In that case, you will have both of them divided by 2. but some cases you get it exactly. So can you get what is the z-score that produced 0.9 as the area? Can anybody find out quickly? What z-score produced 0.1, 0.9 rather, as the area? I believe now you can flow with the fact that we are solving from left to right, so we're using 0.9. You cannot use 0.1 here. So what's the z-score that produced an area of 0.9? Do we have any answer right there? Z-score with an area of 0.9. 1.38. Is it 1.38? Can you check better? Can you check better? 0.9. Is it 1.38? Thank you. 1.28. I agree with 1.28. So this means this place is 1.28. Of course, you can see now that we could not get our value from using a normal table, so we had to go and use our standard normal now. But this is where I need you guys to now pay attention. You cannot go on now to say the 90th percentile of the height of American male is 1.28. This is why. This your answer is a standard normal situation. Normally, if you had a table that could produce this answer from this side straight up, this one here, you would have just gotten an answer and that would have been a perfect answer. But here, this is a z-score answer. 1.28 doesn't represent the situation we are dealing with here, because this one has a mean of 0, standard deviation of 1. So what you have to do now, this was your x-score. Don't forget, we use our x representing a random variable of height of American male. This was our z-score. You know the x-score. The x-score is what you are looking for that will give you the height. Look at it here. Let me try and help you guys here. Imagine you went on to conclude that this was the answer. How does it feel? They told you that the mean of the height of American male is 176.3. You now said the 90th percentile of the height of American male is 1.28. It doesn't make sense. Obviously, it doesn't make sense. How can you say 1.28 is the 90th percentile? No, 1.28 is the z-score associated with the 90th percentile. So you have to go on to find the x-score. That means the actual value. This is the z value. So don't always forget that. 90th percentile, you want an actual value. What answer? The answer you get here, first of all, let me tell you, from what you can see right here, if this place is 176.3, this place will be greater than 176.3, because obviously you can see this is the 50th percentile, this is the mean. More like the 50th percentile if you get that part. So the 90th percentile will be greater than 176.3. And that will be the height that you will say 90% of people add exactly that mark or less than that mark. So 1.28 is just the z value. You have to now go on to find the corresponding x value, as I prefer to call it. Now, how do you do that? Very simple. You use your knowledge of standardization. Now, when we wanted to standardize normally, you were saying z equals to, I'm sure you guys remember this, when you wanted to standardize. And let me tell you guys quickly, sometimes they ask questions where they will just tell you to get the standard score. There's questions like that in objective. Find the standard score and they'll give you the mean, they'll give you the standard deviation, they will give you the x-score. Find the standard score. This is what they're asking you to do in that case. They say find the standard score. What they're saying is for you to just do this. Whatever the x-score was, subtract the mean from it. In short, find the standard score is as saying standardize. That's what they're asking you to do. So don't get yourself into any quagmire when it comes to all these languages. Understand what you are doing. Now, since we know this, that we get our z-score this way, now we have our z-score. We have our z-score, but we don't know our x-score. We can use our z-score that we know to go and find our corresponding x-score. So what you have to do is this is the z-score now, 1.28. So we say 1.28 is equals to, we don't have our x-score, x minus, we know our mean. Our mean is 176.3. We know our standard deviation, our standard is 7.1. So this is how you're going to now go and solve for the x value. So in this case now, you go on to cross multiply. That will be x will be equals to 1.28 multiplied by 7.1 plus 176.3. I'm sure you guys understand what I'm doing here. It's just the whole idea around cross multiplication and everything of 185.4 centimeter. Now, this is the conclusion for saying for the 90th percentile. So if this star right here was 185.4, all right? So let me read the question again and tell you the answer now. What is the 90th percentile of the height of American male? The 90th percentile is 185.4, which means that I can say that 90% of American male had that 185.4 or less than 185.4. So this place right here is 185.4. So we're saying 90% of American male, had either this score or less than this score, which you can see right here. Which also means that 10% of people had higher than this score or this score. That's just the meaning. It's that simple. You guys can see it's so simple. All right. So let me see what you guys will do now with this other question. This other question now is still on the question we have solved. It has to do with in this other case we talked about adult American female. I'm sure you guys should have it in your notes. So it's very similar to this other question, but I want you guys to solve it. In this case now, you were given you are asked to find the 10th percentile. In this case, it's the 10th percentile. The 10th percentile. I'm solving a different question already. The 10th percentile is what you're asked to find here. And you're not dealing with adult American male now, you're dealing with adult American female. So now, your mean in this case, I believe you guys should have it in your notes. Your mean is trying to find the mean value here. Okay, yeah, the mean is 162.2 and your standard deviation is 6.8. All right. So you guys, can you attempt this question quickly? What is the 10th percentile of the height of American female? Now, in this case now, your mean is 162.2 and your standard deviation is 6.8. Can you guys attempt this very quickly? So can you guys attempt this and what's your answer? What's your response? So of course, we will not be using the same diagram, obviously. These are very great theory questions where they try to hook students on their knowledge of percentile and the knowledge of normal distribution. Is a very, very proper question for an A-level exam. So you have to be very careful to make sure you really understand the subject. Now look at this question we're dealing with now. We are trying to find a 10th percentile. As I told you already, of course, you're dealing with a normal distribution here. The mean of this is 162. It's mentioned about the mean, so the midpoint is 162.2. Now you're trying to find the 10th percentile. So obviously, the 10th percentile, that means I'm looking for the height in which 10% of the people had either that height or less than that height. 10%, only 10%. If this is all 100%, 10% will be around here, obviously. So I'm looking for a score now. I'm looking for a score in which 10% of the people had that score or less than that score. So this is how it's going to look like. 10% of the people had this score or less than this score. This is the midpoint. That's about 50 percentile. So it cannot be more than 10% cannot be here. It has to be less than here. It has to be in this place, less. So what do I have to do here? Of course, this is going to be an area of 10%. That will be 0.1. This right here will be 0.9. That means 90% of people had higher than that score or that score. That's the meaning of that. All right. Good. Now that you know that, what do you have to do next? You have to go on to do this because you don't have a normal distribution that has all these parameters. So you have to go on to use a standard normal distribution to find this. So you want to find this Z score. The Z score is there with 0.1 as the area. So you want to look for a Z score that has 0.1 as the area. You go on to find this on your Z table, you will get minus 1.28 as a Z score. Then you recollect that your Z is equals to X minus mu over sigma. Obviously, you know that you don't have, this is the Z score, you need to go and find the X score. So what you want to find here is to say minus 1.28 equals to X minus mu over sigma. Now, minus 1.28, you can fix in your parameter. Your mu was 162.2, your sigma was 6.8. Then you go on to solve this, of course, using mathematical rules, cross multiplication and the likes. You would have your X being equals to minus 1.28 multiplied by 6.8 plus 162.2. And then you'll be having a total of 153.5. This invariably means that the 10th percentile is 153.5. You can see right here, it's less than the 50th percentile. That means 10% of people had this score or less than this score. So simple and straightforward. That's what you need to know about percentile. Now, there's another version of this that I need to quickly talk about also, where they use the word exceeded or not exceeded. And this one is also meant to trick students into a trap. Well, I don't want that to happen, so I want to give clearer. Now, the use of the word exceeded, I'm sure you guys understand all this. We don't need to spend too much time. You guys understand. You can go on to solve more questions. Now, look at this. They use the word exceeded. Sometimes they say not exceeded. These are what you will be seeing sometimes when they are trying to talk about percentile also. All right. So you need to really understand the use of these words. I would love to give an example. And not exceeded and exceeded, as I said already, they are all still talking about the same thing, and that is percentile. All right. Now I want to read this question out to you. Don't know if you can write it down, or you can write it down. Let me try and just say it. So you have a very interesting question, and the use of the word exceeded and not exceeded was used. the score in a test, okay, let me try and put that here. So the score in a test are normally distributed with a mean of, so the score in a test now are normally distributed with a mean of 40 and a standard deviation of 8. All right, pay attention to what I just said. Of 40, a standard deviation of 8. Now, the question went on to say, find the score. Look at now. This is the language now. Find the score exceeded, look at the word, in 5% of the test. Look at it. They told you that the score in a test with mean of 40, standard deviation of 8. You're now told to find the score exceeded in 50%, in 5% of the test. Now, this brings me to the use of, to explaining how this relates perfectly with percentiles. Now, I want you to know that they can also ask the question and say, find the score not exceeded in 5% of the test. So how do you understand this? So when you see the word exceeded means that the score that 5% of the people exceed. So find the score exceeded, the score that 5% of people exceed. Listen carefully. Let me repeat that. Find the score exceeded in 5% of the test. The interpretation of this is that the score that 5%, of course, of the population of this class doing the test exceed. Let me draw a normal distribution here and let me use it to explain it. We have 100%. Everybody is 100%. The whole shape represents 100%. When I say find the score exceeded in 5% of the test, I told you that the way to read this will be, what is the score that 5%, of course, of the people exceed? What is the score that 5% of the people exceed? I'm saying that one more time. What is the score that 5% of the people exceed? If you want to draw this on the diagram, let me tell you what it's going to mean. You have all this. I'm going to take this place as 5%. I'm going to take this place as 95%. That will be 0.95. Whereas this place will be 5%. That will be 0.5. Now, look at the meaning of this. Find the score exceeded in 5% of the. That means find the score that 5% of the people exceed. That means this will be the case. A score here, there's a score here now that 5% of the people, of course, they mean another way of saying it, 95% of people do not exceed that score. Sorry, 0.05, sorry. So find the score that 5% of people exceed. 5%, look at 5% of them. They have more than that score. Exceed. The meaning of the word exceed means more than, obviously. Another way of seeing it, as I told you guys, you can use two ways to always talk about percentiles. Is find the score that 95% do not exceed. So you can see now, 5%, if you say find the score exceeded in 5% of the test, that means 5% of people had more than that score. The score exceeded in 5% of the test. 5 people had more than that score. You can see it here. That means this is going to be how the diagram is going to look like. So now, what percentile are we dealing with here? We actually what you actually did. Let me see if anybody can actually answer this rightly. What percentile are we dealing with in this question? This particular question. What percentile are we dealing with? Anybody? What percentile are we dealing with in this question? I want to see if you guys can really flow. Wow, perfect. 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 That's nice. I love you guys. You are doing, you actually, that's really nice. We're dealing with 95 percentile. 95 percentile is what we're dealing with. That's really great. So when you said find the score exceeded, 5% of people had more than that score. That means 95% of people had that, less than that score or that score. So this is a question of 95 percentile. But you see how it was framed in such a way that you don't even know this was percentile if you're not very acute in looking at what they are saying here. So it's a very simple question, but it was framed in such a way that students could get confused. So find the score exceeded in 5% of the test means find the score that 5% of the people exceed. 5% of the people had more than it. What's that score? Wetin be that score? Where 5% of people had more than it. What's this score here? So obviously, you know what to do here now. Can you guys find this quickly? This is something. Can you just get the answer to this just like in 60 seconds? If you know already what you're doing, you are trying to find this place now. This is 0.95. You know your table don't reach from right to left, you reach from left to right. So obviously 0.95 is what you're going to be looking for in your Z table. You are going to look for what is the score associated with 0.95. Now, when you are getting that score, you know that that's just the Z score. You have to now go and find the X score because they are asking you for the score now. They're not asking you for the Z score. They actually mark that 5% of people will have more than it. So of course, you know this place will be 40 because the mean is 40. This place will be 40. So whatever mark you are dealing with will be more than 40 because that mark 5% add more than it. Have anybody got an answer already? So obviously, if you find the X value associated with, the Z score associated with that place, what do you get? What's the Z value? Oh, you people are getting two different answers. Why? I think the corresponding Z value, if this was on a Z value, is 1.6. 1.645. So the Z score is 1.645. So you go on to say Z equals to X minus mu over sigma. That means Z 1.645 equals to X minus 40 over 8. You go on to find your X to be 1.645 multiplied by 8 plus 40. That should give you a total of 53.2. All right. So that's just it. 53.2. So that means now I can say now that the score exceeded in 5% of the test, or I can say the score in which 5% of the people had more than that exceeded it was 53.2. So this place now is 53.2. 53.2. You can see that 5% of people had more than 53.2. That's the meaning of it. 5% of people had more than that score. All right. Now, the second aspect I said can come out in if it's not exceeded. The other aspect you can see. So let's solve one question on not exceeded. Not exceeded. Now look at this question now. The weight of fairy cakes. The weight, of course, we're done with this question. The weight of fairy cakes in gram produced by a local baker are assumed to be normally distributed with a mean. The mean of these fairy cakes is 160 and standard deviation is 5. All right. So let me read that one more time. The weight of fairy cakes in grams produced by a local baker are assumed to be normally distributed with mean of 160 and standard deviation of 5. All right. Now, the question now is find the weight. not exceeded. Find the weight. Now, not exceeded by 1% of these fairy cakes. Find the weight not exceeded. Look at the question there now. Not exceeded. Find the weight not exceeded. Find the weight not exceeded. That means in this case now, you are asked to find the weight that 1% of the cakes do not exceed. Another way of interpreting is by 1% of the cake. You can also say, find the weight that 1% of these cakes don't exceed. That means only 1% of the fairy cakes have weight less than or equals to that value. Let's draw the normalization curve and let me use it to interpret this. Of course, this is 160. Now, find the weight not exceeded by 1% of these fairy cakes. That means only 1% of these cakes have weight less than or equals to this. As I said, you can look at it as saying the weight that 1% of this cake don't exceed. 1% of the cakes don't have more than this particular weight. So if this is 1%, let's take this to be 1%. 1%. This is 0.01. 1%. Find the weight not exceeded by 1%. 1% of these fairy cakes, they don't exceed this particular weight. So this is what you're looking for. The weight that 1% don't exceed. So there is a weight now. 1% of these fairy cakes don't have more than that weight. So this the major thing here is not to really solve, but to give understanding of how to interpret these questions. That's the major thing, because I believe you guys at this point, you already know how to solve, but how to interpret the use of this word exceeded and not exceeded. So when they said the weight not exceeded by 1% of these fairy cakes, that means the summary is that only 1% of the fairy cakes have weight less than or equals to this. Or you can say it as the weight that 1% of the cakes don't exceed. So this is 1% of the cake now. Of course, that means 99%, 0.99, 99%, they will have weight, that particular weight you are looking for. They will have weight more than that. So 99% have weight more than this. But 1%, they don't have weight more than it. They don't exceed this weight, particular weight. 1% don't exceed this weight. So they have weight either this or less than this. So what's the value for the weight in this case? By the way, what percentile are we dealing with here? What percentile is this? Can anybody tell me what percentile we're dealing with in this case, in this particular question? Yeah, the first percentile. We're dealing with the first. Thank you very much. You're dealing with the first percentile. The first percentile. So what do you get as your value? Of course, you know what you have to do is to go on to find the corresponding Z score first. What was your Z score in this case? Your Z score was, is it 2.32? What was your Z score? Okay, looks like you guys are getting the same answer, 148.4. So your Z score, as well with this, was minus 2.32, all right? So now, if you've gotten this place, of course, that's not what you're looking for. You're looking for the actual X score. So to find the X score, you know that Z equals to X minus mu over sigma. So your Z obviously will be, sorry, your minus 2.32 will be X, which you're looking for, minus, you're dealing with mean of 160. Understand? Here will be equals to minus 2.32 multiplied by plus 160. When you're done with this, you should get a value of 148.4, which is approximately 148. Okay, minus 2.33. Okay, it's okay. It's okay. It's okay. All right. So, okay. So, guys, this is all good. So, the major reason why we had this class was to clarify everything surrounding percentiles under normal distribution. So, understand the use of the word not exceeded, exceeded. Take your time to wrap your head around this. And guys, I want to caution you for something I want to caution you on. Understand this. Of course, one of the things that will help you guys so much for your exam is to use the formulas well. Using the formulas well will give you a lot of expertise and skillfulness in knowing what to do. One of the major confusion people used to have, let me tell you, is that I'm telling you guys this based on my experience. This is the formula for standardization. And this has to do with normal division. You are trying to bring something from X score to Z score, or bring something like in this case from Z score to X score. Now, you need to be very careful that this formula and test statistics are not the same thing. So this is where people used to make real mistakes. All right, where they go on to confuse this formula with the test statistics, where we had, if you remember the test statistics I gave you guys already when dealing with significant testing, we have not started solving that. We'll start that one later. When I said X was, we had X bar minus mu naught over S over square root of N. Don't confuse these two formulas. All right. This is Z calculated, and this is Z calculated, the test statistics when you are dealing with normal distribution, sorry, when you're dealing with significant testing, whereas this has to do with standardization. So maybe that's why we always try to identify this with writing it as Z calc. Z calc, all right? Use this as Z calc and don't confuse the two. So I just need to state that very quickly. This standardization, use this very well before we start going to Z testing so that you are not confusing both. They are not the same thing. Please, I'm saying this for those of you that may probably want to interchange this. They are not the same. This standardization, this is test statistics under test of hypothesis. So guys, this is where we're going to stop for today's class in the morning. We'll be meeting later today. And this time around, we'll be going thoroughly into Z testing. So Z testing, 8 o'clock. All right. So this is where we're going to stop. You guys, make sure you go through this and solve many questions as possible to make sure you are very familiar with how to get things done. Thank you guys. And I wish you guys all the best in your coming exam. I wish you all the best. Take care of yourself. Bye-bye.